Hi, it's Algebra 2, Section 3A, Mr. Prykuta's class. Sorry I could not be here today, but here's the video on this section. Before beginning, my suggestion is to use the math review in the front of the packet. Do those questions. I'll reveal the answers at the end of this video. Today's lesson on 3A will be on the sum and product of roots of a quadratic equation. If I start by thinking about this quadratic equation, 2x squared minus 5x minus 3 equals 0. That quadratic equation can be solvable. We learned three methods: factoring, quadratic formula, and the complete the square method. If I was to use factoring, it would become x minus 3 times 2x plus 1 equals 0. I'd have to use the illegal method. Then I would end up with answers of 3 and negative 1/2. Now notice, I said the sum of the roots. The sum of those two roots, or solutions, as we sometimes call roots, in this case would be 5/2 for the sum, and the product would be negative 3/2. Now notice, this sum, if I was to put that in front of the x term in a standard quadratic form, and this negative 3 over 2 in a constant term of a standard quadratic form, notice how it looks similar to this one, except the 2 is in the denominator. So if I just multiplied everything by 2, it would become that same exact form. So really what I'm seeing here is that the sum of any two roots in a quadratic equation, we'll call it R1 plus R2, is equal to negation of B over A. And the product of the roots, or R1 times R2, is equal to C divided by A. Remember, this is in the standard form ax squared plus bx plus c equaling 0. We always want our equations to equal 0. So if I was to look at these first three quadratic equations, number 1, x squared minus 4x plus 13. The sum would be the negation of negative 4. So negative 4 divided by the a of 1, or just 4. The product would be 13 divided by 1, or just 13. Number 2, the sum would be the negation of 8, so negative 8 divided by 4. The product would be 17 divided by 4. This negative 8 over 4 would become negative 2. Sorry, let me fix that. Negative 2, and the product would be 17 over 4. Yes, you could write that as 4 1/4, but you don't need to. You can leave it perfectly fine as an improper fraction. Finally, number 3, the sum here would be 1/3, and the product here would be 5/3. Did you catch the mistake? The sum is not 1/3. The sum should be negative 1/3. Again, when you're doing that sum, it's a negation of this term. Make sure you don't make that mistake. Now, another thing we can do with this idea of the sum and product is I can take two roots and turn them back into a quadratic equation. Take, for example, the roots 3 and negative 7. If I take the two roots, 3 and negative 7, and find their sum, 3 plus negative 7, that would equal negative 4. If I do their product, 3 times negative 7, that would be negative 21. Now, why are those important? Because this negative 4 would actually be equal to the negative b divided by a. This negative 21 would actually be equal to the c divided by a. Notice how neither one of them have denominators. So in both cases, the a value would equal 1. The b value, well, since it's a negation of b, I wouldn't use negative 4, I would use positive 4. And the c would absolutely be the negative 21. A is 1, B is 4, C is negative 21. So the quadratic equation would be x squared plus 4x minus 21 equals 0. Always ending with that equals 0. Let me fix this. Number 5, now we see a similar problem, only now I have this fraction 1/2. So when I go to solve this, I'm going to do the same exact thing. I'm going to add 5 plus 1/2. That gives me 11/2. I'm going to do 5 times 1/2. That gives me 5/2. 11/2 is my sum. 5/2 is my product. So this is equal to the negative b over the a. This is equal to the c over the a. So my a, notice both denominators, is 2. So the a is 2. The b, negative b is 11. So positive b would be negative 11. And c would equal 5. So when I substitute the a, b, and c into that standard form, I get 2x squared minus 11x plus 5 equals 0. Now in both these cases, they were nice rational numbers. What if we get an irrational, such as 1 plus radical 7 and 1 minus radical 7, conjugates of each other? I'm still going to follow the same exact pattern. I'm going to find their sum, I'm going to find their product. 1 plus radical 7 plus 1 minus radical 7. Well, positive radical 7, negative radical 7, they cancel. That equals 2. 1 plus radical 7 times 1 minus radical 7. Yes, those are conjugates. The product of two conjugates is always a real rational value. So in this case, it would be 1 squared times radical 7 squared. 1 squared minus radical 7 squared. So that's 1 minus 7, or negative 6. Notice, no denominators. My a is 1, my b is... No, my b is negative 2. And my c is negative 6. Remember, again, the negation of that term, because it's the negative b over the a. It's the positive c over the a. So the equation would be x squared minus 2x minus 6 equals 0. Lastly, I have an imaginary number of 6i and negative 6i, the plus and minus 6i's. I'll follow the same exact pattern that I did for the previous 3 questions. 6i plus negative 6i. They equal 0, positive and negative. 6i times negative 6i. I'll put them both in parentheses. That's equal to negative 36i squared, which we know to turn into just positive 36. Again, if I equate this as being my negative b over a, and I equate this as my c over a, no denominators, a must be 1, b in this case turns into a 0, and c is 36. Following that pattern, I notice since I have a b of 0, I don't need to have a b term. So I can simply write the equation x squared plus 36 equals 0. Those 4 equations can actually be checked on your calculator. Type those equations into your calculator and you'll see the value at which they cross, the parabola crosses the x-axis will match the 2 roots. Again, the roots of the parabola are where it crosses the x-axis. 2 more questions. First of all, if I gave you the equation 3x squared plus bx plus 5 equals 0, and I told you that one of the roots in this equation is 5, So I know one root already to be 5. What is b? Well, I don't know what b is, but I know b has to do with the summation. Number 5, well, that has to do with the product. So maybe if I use that information, I could calculate out what b is. Since I know c and I know a, I know my product is going to be 5 over 3. So I can say 5 times what R2, or the second root, will equal 5/3. The answer is 1/3. But that doesn't give me my answer. Or does it? Because that just told me what R2. I really want to know what's B. What's the beef? So I can use the other concept here, which is the sum. I could say my R1 plus my R2 is going to equal the negative B over A. So in this case, 5 plus 1/3 is going to equal the negative B over A. Again, turn 5 into a fraction with a denominator of 3. That's the same as 15 over 3 plus 1/3 is the same as the negative B over A. That's the same as 16 over 3 equals the negative B over the A. Notice the A is 3. That matches up to my equation. So my negative B is 16, so B is negative 16. Again, this negative B was positive 16, so B is 16. Let's talk about one more before we end. Now let's reverse this. Instead of trying to find the B term, let's try to find the C term. So here I have this equation, 2x squared plus 3x plus c equals 0. And I'm going to tell you now, one of the roots of this equation is 1. Yes, you need to have at least one of these roots to figure out this kind of a question. Since I'm given my B and I'm given my A, I could use the sum. The sum, remember, is negative B over A. So in this case, I'm going to do 1 plus my second R is going to equal that sum of negative 3 over 2. Subtract 1 from both sides. What do you get? Negative 5/2. Notice this matches up again that my A is 2. But I want to know what's C. C we can find by doing the product. R1 times R2 equals C over A. In this case, we know R1 to be 1. We know R2 to be negative 5 over 2. Put that in parentheses, negative 5 over 2. Hey, notice, the 1 cancels out because anything times 1 is itself the multiplication identity. Hey, the A matches up to the 2, so C must equal negative 5. Again, you can plug those values in, put them into the calculator, see where the parabola crosses the x-axis as a way of checking this. Make sure to work on the classwork page as well as the homework page. I'll be checking over this information on Monday, when you will be getting your exit ticket for this information. Make sure to work together on this, learn from each other, and I'll see you when I get back.